Hello, welcome to the second lecture for Mathematics Class 11, Chapter 8, Sequences and Series. So, in the previous class, we learned the concept of, what are sequences, and we also looked briefly into what are series. Okay, so sequences, as we have seen, it's a list of terms or items that are arranged in a sequential or ordered manner. Okay, so the list itself, the terms which are which are in the sequence, they follow a pattern. Okay, there is some relation between the terms, between each of the terms in a sequence. Okay, so this is what we saw. So just a quick recap. Sequences. Okay. So what are sequences? Sequences and arrangement of objects slash terms in an ordered manner. Okay, so suppose you write, you give the sequence in terms of say A1, A2, A3, A4, all the way up to AN. Okay, so there are n number of terms. Suppose this is a sequence. Okay, n number of terms in the sequence. And A1 and A2 will have a relation between them. Okay, either A2 would be some sort of a multiple of A1. Okay, it could be just like by adding or subtracting some term with A1, you can get a new term A2. Okay, so this is what we have seen even previously, like what are sequences. We also learned about how you have finite sequences and infinite. It depends on the number of terms that are described in the sequence. Okay, so this is something that we have seen before, and we also saw briefly that a series is the sum of all of the terms in a sequence. Okay, all the way up to AN. So this is a series. Okay, so in a sequence, it's only a list of terms, but in a series, it's the sum of all of the terms that are contained in the sequence. Okay, we also saw some differences when we have sequences and series. So one of the main differences that is there is that in a sequence, when you are writing a sequence, the order of the terms, okay, how you are representing them, it matters. Okay, but with respect to series, the order in which you add the terms, okay, the order of the terms of the sequence being added is not important. Okay, so this is something that we learned. Now we saw, for example, if we, write a sequence of all the even number terms. So there is a relation between them. Okay, so when we look at it, we can understand that there's a relation. But sometimes, we do not have a definite relation existing between, or you cannot find it out very easily. So what then happens is, suppose for example, we take the example of the arithmetic sequence. Okay, so in arithmetic sequence you will have A1, A2, A3, and so on up to AN. Okay, so if you remember in arithmetic sequence, a number is added or subtracted from the preceding term to get the new term. Okay, so that means for getting A2, you need to either add or subtract a certain number to A1, okay, to get A2. So in other terms, we can say that there exists a quantity called common difference. Okay, so this you can write as D, and this is equals to A2 minus A1. Okay, so that means A2 will be A1 plus D. Okay, this D is added to each and every preceding term. Okay, so when you write A3, it will be what? A2 plus D. Okay, so this D is added or subtracted. Okay, so right now we are only considering if it is a negative value, then it will obviously get subtracted from each term. Okay, subtracted actually to or from each term to get consequent term or consequent term. Okay, so then you can write that sequence can be in the form, you have A, which is the first term, suppose, then you have A plus D, A plus 2D. Okay, why A plus 2D? Because then if you write, A plus D is your preceding term, so you will have A plus D and then you add another D, so you have 2D. So similarly, you have A plus 3D and all the way up to A plus. Now you see that the first term, okay, so there is no D, so this is plus 0D. Then this is 1D, 2D. Okay, so the second term has 1D. Okay, so this is your second term and you have only 1D. So that means your last term would be A plus N minus 1D. Okay, so this is the way that you can write an arithmetic sequence. Okay, an arithmetic sequence or an arithmetic progression. So therefore, the common difference D is equals to A2 minus A1. Okay, then you can write the general term. Okay, for any n, general term. Okay, say for R position can be written as A plus R minus 1 D. Okay, so you can write this as AR is equals to A plus R minus D. So in similar way, you can write the last term. Okay, the last term is when you have say A N D. Okay, so this is these are few of the concepts that we will use, okay, when we are trying to solve any examples where you're asked to either find a certain term with R, or you have to find the last term, or you can write the entire sequence in the form of your this last term, or a general term. Okay, so we will see some examples of this. So just wait a moment. Okay, suppose the question given to you is an is equals to 3n plus 2. Okay, so this is given to you, suppose is the sequence. Okay, so now the sequence is not given as a series or sorry, a list of all different terms. Okay, you are given in a very general form the sequence. So the question is, write the first 4 terms and find D. Okay, so D is the common difference we have to find, and we also have to find the first 4 terms. So when your an is equals to 3n plus 2. So let's start with n being 1. So the first 4 terms, the first term would be where n is equals to 1. So your a1 is equals to 3 into 1 plus 2. So a1 is 5. Okay, now if you have a2 for when n is equals to 2. So that is 3 into 2 plus 2. Okay, so this would be 8. Then the next one is n is equals to 3. So you have a3. So 3 into 3 plus 2. So this is 9 plus 2, that is 11. And you have n is equals to 4. A4 is equals to 3 into 4 plus 2 is equals to 14. Okay, so these are the first 4 terms of the sequence an is equals to 3 plus 2. Now we want to find the common difference. Okay, now for common difference, we could have, if you can actually, it's very difficult to find it out from this, kind of the way that the sequence has been described over here. So what we do is, to find the common difference D, we subtract the first term from the second term. Okay, so your A2 is 8, A1 is 5. So your common difference is D. Sorry, D is equals to 3. Okay, so this is how you can solve this. Now let's take another example. You have an is equals to n minus 5 by 4. Write the first 4 terms and find B. Okay, so you have n is equals to n minus 5 by 4. So suppose when your n is equals to 1, you have a1 is equals to 1 minus 5 by 4. This is 5 minus 4 by 4 minus 1. N is equals to 2. A2 is equals to 2 minus 5 by 4 minus 3 by 4. N is equals to 3. A3 is equals to 3 minus 5 by 4. This is minus 2 by 4 minus 1 upon 2. Then you have n is equals to 4 because we have to find up to the 4th term over here. So you have a4, you have 4 minus 5 by 4 minus 1 by 4. Okay, so this is what we get, the first 4 terms. Now if you want to find D, so D you can get as minus 3 by 4. So minus the first term. So first term is minus 1. So this becomes plus 1. So this is what? Minus 3 plus 4 upon 4, you have 1 by 4. Okay, so this is what we get. Now suppose, just to cross check, if you have to find an as a1 plus, n minus 1d. Okay, so your a1 that we had found is minus 1. Okay, plus your n is what? 1 upon 4. Sorry, your n, suppose we are trying to find the second one. So n is 2 minus 1, and d we found was 1 upon 4. So what do you get in this is minus 1, okay, plus 1 upon 2 minus 1 upon 4. Okay, so this if you get, have minus 1, you have plus 2 minus 1 by 4. So this will give you minus 1 plus 1 upon 4. So this you get minus 4 plus 1 by 4, and this is minus 3 by 4. So you can see A2 is, we have calculated with respect to, just substituting n everywhere. We had got A2 as minus 3 by 4, and even when we use with the common difference, we could see that A2 comes as minus 3 by 4. Okay, so your D is very important. Okay, so with the D, you can find out any of the terms. Okay, just not the fourth term as it is asked here. So suppose you have to find the 10th term of this. Okay, so when we are saying that an is equals to n minus 5 by 4, okay, we got d as say 1 by 4. Okay, yeah, d is 1 by 4. So by the other method or the other formula, you can get, just like if you do not have any of the other terms, you don't have a9 or anything given to you, so you can just calculate it as your minus 1 is the first term. Okay, and you have plus n is 10 minus 1 1 upon 4. So you can easily get this as minus 1 plus 5 by 2 minus 1 by 4 minus 1 plus minus 1 by 4 minus 1 plus 9 by 4 minus 4 plus 9 by 4. So that is 5 by 4. Okay, let's see if it's the same thing over here when we get your n is 10 by 4. So that is again 5 by 4. Okay, so whether you are given the sequence in this form or you're just given your n and d, okay, n is any term that you have to find, you're only given d, you can still find the different terms that are existing in that sequence. Okay, let's take another example. An equals to n minus 1, 1 minus n, 2 plus n. Okay, find the 20th and 21st term. So suppose when we take n is equals to 20. So you have 19 multiplied by, over here this is minus 19 multiplied by 22. So that actually gives you minus 7942. Okay, we'll just cross check it once. Yeah. Then we have to find the 21st term. Okay, so n is equals to 21. So A21 is equals to 21 minus 1 multiplied by 1 minus 21, and we have 2 plus 21. So what you get is 20 multiplied by minus 20 multiplied by 23. So this turns out to be minus 920. Okay, 9,200. So this you can see, it's a complex one. And so we can find it over here. Okay, so the sequence over here, it's a bit difficult to probably it will be a difficult, the relation might not be exactly equal to just a common difference between the two terms in this kind of a sequence. Okay, so let's take another example. So you have a sorry, let a is equals to 1. Okay, the a1 is equals to 1, and a n is equals to a n minus 1 plus 3. Okay, where your n is supposed to be greater than or equal to 3. Okay, now we have to find the first 5 terms. Okay, so a1 we know is already equal to 1. Okay, now we have to take n is equals to 2. So then your a2 then becomes, you have a n minus 1. So that is a1 plus 3. So that is again 4. Okay, then for n is equals to 3, the third term a3 is equals to a n minus 1. So 3 minus 1, that's 2. So a2 plus 3. So that is 4 plus 3 is equals to 7. Then you have n is equals to 4. A4 is equals to A3 plus 3 is equals to 7 plus 3 is equals to 10. N is equals to 5. So A5 is equals to A4 plus 3. So we have 10 plus 3 is equals to 13. Okay, so this is how, we are already given over here. So suppose, you have the common difference you can very easily find from here. So if you have a n minus 1, okay, that usually gives you your d. So d is equals to 3 over here. Let's take some other examples. Suppose we have q is equals to, sorry, not q is equals to, the question is that your an is equals to root 2 raised to n. Find the first 5 terms of the sequence. Okay, so suppose you have a1 is going to be root 2 itself, a2 will be root 2 the whole squared, so that's 2, a3 root 2 the whole cubed, so that is 2 root 2, a4 is root 2 by 4 raised to 4 is equals to 2 into 2, that's 4. And if you have a raised to 5, so we have 2 raised to 5. So again, that is 2 into 2 into root 2. Okay, so this is root 2 square, root 2 square. And then there is root 2. So this is 4 root 2. Okay, so this is how you can find even when, you have such kind of sequences. Okay, so the sequence up to the 5th term will become root 2. Sequence is root 2, 2, 2 root 2, then you have 4, and then you have 4 root 2. Okay, so you can see that this is the sequence up to the fifth term. Let's take another example. -1 by 6. Okay, so this is a bit different. So over here, it would be difficult to even find D directly over here. So let's see. Okay, so we will find the first 5 terms and D. Okay, so we will find the first 5 terms of the sequence and also the common difference D. So when you have n is equals to 1, so your first term becomes 2 into 1 minus 1 by 6. So that is 1 by 6. Okay, let's take n is equals to 2. So your A2 becomes 2 into 2 minus 1 by 6. So you have 4 minus 1 by 6, 3 by 6, 1 by 2. Okay. Then let's take the third one. A3 is equals to, so 2 into 3 is 6, 6 minus 1, 5 by 6. So now if you have n is equals to 4, A4 is equals to 2 into 4 minus 1 by 6. So you have 2 into 4, 8. 8 minus 1 is 7. 7 by 6. And the last one, we want to find up to the 5 terms. Okay, so the fifth term is n is equals to 5. Okay, so A5 then becomes equals to 4, sorry, comes 2 into 5 minus 1 upon 6. So this is 10 minus 1, 9. So you have 9 by 6. And you have that as 3 by 2. Okay. So your sequence up to 5 terms is 1 by 6, 1 by 2, 5 by 6, 7 by 6, and last one is 3 by 2. Now to find D, you can take 2 consecutive terms. So let's just take the first term and the second term. Okay, so you will have A2 minus A1. So your A2 is 1 by 2 minus 1 by 6. So this becomes your 3 minus 1 by 6. So that is 2 by 6, 1 by 3. Okay, so this is 1 by 3. So let's just take D and find out. Okay, just add a slide. Yeah. So over here, we are getting D as 1 by 3. Okay, so let's try to get some other term. Okay, so your D is equals to 1 by 3. Okay, now let's find the 20th term. Okay, with D. Okay, we won't use the sequence as it is given. We'll find the 20th term using the value of D. Okay, so your A20 would be your first term plus n minus 1. Okay, so n over here is 20. So you have 20 minus 1, and your D is multiplied by 1 by 3. Okay, so this will give you what was A1. A1 we had got as 1 by 6. So 1 by 6 plus 19 by 3. Okay, So you can get this as 1 plus over here 19 multiplied by 2. So that's 38 by 6. So this is 39 by 6. Okay. So just to cross check, sorry, if we take it using the sequence as it is given, where you have an is equals to 2n minus 1 by 6. Okay, so our n is a20 will be 2 into 20 minus 1 by 6. So that itself gives you 40 minus 1 by 6, that is 39 by 6. Okay, so actually if you reduce it, this would actually turn out to be 13 by 2. Okay, if you divide the numerator and denominator by 3 itself. So this is 13 divided by 2. Okay, so these two are the same. So whether you are using, the general form of the sequence that is given to you or the value of d as it is calculated, you can find the sequences. Okay, so let's take a few more examples. Suppose the question is an is equals to minus 1 n minus 2 divided by n square. Find the eighth, the 7th, 8th, and 13th terms. Okay, so your an is equals to minus 1 raised to n minus 2 multiplied by n square. So if your n is equals to 7, your a7 is equals to minus 1 raised to 7 minus 2, 7 squared. Okay, so now this would be your minus 1 raised to 5. 7 squared is 49. So any whenever you use any power, okay, with respect to your minus 1, okay, so if it is an odd power, your minus 1 remains minus 1. If it's even even number power, then your minus 1 becomes 1. So over here the power we have is odd, so this will remain as minus 1, so this becomes minus 49. Okay, so similarly, if you have n is equals to 8, so you will have a8 is equals to minus 1, 8 minus 2, then you have 8 squared. So you have minus 1 raised to 6, 8 squared is 64. And now since we have the power of minus 1 as an even number, this will become 1. So this is 64. Now let's take n is equals to 13. So you have a 13 is equals to minus 1 is to 13 minus 2, 13 squared. Okay, so over here you can see that minus 1 would be raised to now minus 1 raised to 11. Okay, and 13 squared is 13. It's 169. Yeah, so that is 169. Okay, and since the power is an odd number, this becomes minus 169. Okay, so over here you can see that this is how your sequence will go. Okay, let's take another example. So you have an is equals to, just wait a minute. Okay, and we want to find the 4th, 15th, and 20th terms. Okay, so suppose we take our n is equals to 4. So this will be a4 is your n is what? 4, 2 minus 4 upon 4 plus 2. Okay, so that is 4 into minus 2 upon 6. So you can easily get this as 3. So this is minus 4 by 3. Then suppose we have n is equals to 15. So A15 is 15 divided by 2 minus 15 upon 15 plus 2. This is 15 multiplied by minus 13 and this is 17. Okay, so now we will find your 15 multiplied by 13. So that is minus 195 by 17. Okay, the next one we have is n is equals to 20. So A20 would be 22 minus 20 upon 20 plus 2. So that is 20 multiplied by minus 18 and you have 22. This is 10. This is 11. Okay, so this is minus 180 by 11. Okay, let's see if we can, find any sort of D for this. Okay, so over here, let's find our first and second term also and see if we can find any D. First, second, and third. Okay, so your an is equal to n2 minus n upon n plus 2. Okay, so let's find our a1. So that is 1, 2 minus 1 upon 1 plus 2. This is 1 into 1, so this is 1 upon 3. A2 would be 2 into 2 minus 2. Okay, and your n plus 2, 2 plus 2 is equal to then it's 0. Just 2 minus 2, if you have, it will become 0. Let's see A3. So you have 3 into 2 minus 3 upon 5. Okay, because 3 plus 2 is 5. Then what you have is 3 into, you have what? This is minus 1 upon 5. So this is minus 3 upon 5. Okay, so the any sort of common difference is, I think, is difficult to find. Okay, so even if we have a4, okay, we have a4 is equals to minus 4 by 3. Okay, so even if you kind of find the difference between a4 and a3, let's see if we get the d in that sense. That's minus 3 by 5. This will be minus 4 by 3 plus 3 by 5. Okay, this then becomes minus 20 plus 9 upon 15, that is minus 29 by 15. Okay, so you see that in this sense, your D, your common difference is not really existing, okay, easily. So then we can say that this is not, part of your arithmetic progression or any arithmetic sequence. Okay, might be, this can be a part of your geometric sequence or geometric progression. Okay, so we will learn more about geometric progression in the later classes. Okay, so then let's take some more examples. Okay, let's take question is an is equals to n squared by 2 raised to n. Okay, so let's find our A4, A6, A7. Okay, so let's take our A4. So A4 would then be 4 squared by 2 raised to 4. Okay, so if you just first write it in like a simplified expanded form, so since both of them have similar kind of there are multiples, so 2 into 2 is 4 is 4. Okay, so this is 1. Because any which way your 4 squared is 16, and even 2 raised to the power of 4 is also 16. Okay, so they will both get cancelled. So let's take A6 and see. So you have 6 squared upon 2 raised to 6. So you will have 6 into 6 upon 2 into 2 into. Okay, so over here, if you cancel out, so you have 3, 1, 3. So this is actually then becomes 6 upon, you have 4 twos, so 4 twos is 16, so that you have as 3 by 8. Okay, let's take a 7. So you will have 7 squared upon 2 raised to 7. Okay, so now over here we know that 7 squared, obviously 7 cannot be, you know, divided by 2 in any way. So if you just write this as 49 divided by, okay, so now we'll have 2 raised to your 7. Okay, so that is upon 128. Okay, so this is your answer. Okay, 49 divided by 128. So this is another way that you can write. Now let's see if we can find any common difference over here. Okay, so common difference would be A2 minus A1. So let's just solve for A2 and A1 also. So A2 would be 2 squared upon 2 raised to 2 minus your 1 squared upon 2. Okay, so this would become this becomes 1. Okay, so this is 1 minus 1 by 2. So that is actually 2 minus 1. So you have 2 minus 1. So you have 1 by 2. Okay, so we are getting a D, but let's see if your, A3 and, A2, if we get the same thing. Okay, with our A1 being what? A1 would be 1 upon 2. Okay, so let's try with A2. So you have A1 plus n minus D, n minus 1. Your D is what? 1 by 2. So this would be 1 by 2 plus 1 minus 1 by 2. So this is 1. Okay, so your A2 is actually 1. Okay, so we are getting A2 as that is calculated. Okay, and your A3 would then be 1 by 2 plus 3 minus 1, 1 by 2. So this is 3 minus 1, so this is 1 by 2 plus, this is 2 by 2. So this is 1 by 2. Okay, your D actually, your A3 becomes 1 by 2. Okay, so this is a few of the ways that you can, solve for solve different kind of sequences when you are given just like a generalized term. Okay, the nth term. These are all the nth terms that are given for a sequence. So when you are given the nth term for any of the sequence, you can just put in the values of the n, okay, in your this in the expression that is given, and you can find the term with respect to different n of the in the sequences. Okay, So we will stop here today, and in the next class we will go with how we calculate series. Okay, so we will start with series, and we will also see different kind of other types of sequences, like geometric progression, how we can get that the common, that number which is being either multiplied to, or being or used to divide the preceding term to get the newer term. Okay, so we will stop here for today.